Hi, so this is a demonstration of the Overtones series and a just intonated sine wave synthesizer. So to demonstrate the Overtone series, what I've done is I've gone through and taken 110 hertz, 110 oscillations per second, and created and generated each of those tones. Here's a sine wave at 110 hertz. You can see it's a very clean waveform, cycling 110 times in a second. And then to get the overtone series, you simply multiply that out by 1 through 8. And so you can see I've done that. And here it's playing in a loop. And let's listen to it one at a time. And you'll hear an octave of the fundamental pitch, and then an octave above, and a fifth and a fourth above that, giving another second octave. And then the intervals of the overtone series get it increasingly rarefied up till the fourth octave above. So let's hear them one at a let's hear them added one at a time here. So. So now let's hear them together so that we can get a sense of what happens with natural sound when you have the fundamental and all these and an interplay of these overtones happening together. So. So that's the natural overtone series. The next thing that happens with natural sound is they happen in the resonant cavity of a body or an instrument. So that enhances certain overtones and suppresses others. For example, this is very well demonstrated by the Tuvan throat singers, Hun that seem to be singing two notes at a time, and they do so by suppressing certain overtones and enhancing others. For example, the trebly overtones that resonate in the sinus cavity. So let's hear. So to emulate this, what I've done is I've set up some filters. So we're going to run the sound through an EQ filter. So let's start by hearing what happens there. I think it's also interesting to note that you'll see these peaks in the sound that represent the different overtones. You'll see a peak here at 110, 220, and so on. When I play the sound here, check it out. 110, 220, 330, 440, 550, 660, 770, and 880. And there's nothing up here. Okay, so the next thing that happens to a natural sound is it happens in a space. So you get the phenomena of specular reflection, which is like seeing our reflection of light waves in a mirror, or seeing the sky reflected off of calm water. Then the next thing that happens is diffuse reflection, or for sound, that's reverb. And that's, in the case of light waves, that's the way light reflects off when the sun shines on snow and it's so bright that it can actually damage your eyes. But that's, you don't see a reflection exactly of the sun or the sky, but you're receiving the light. That's diffuse reflection, and it's represented in sound by reverb. So let's add those two phenomena to further enhance our sound here of these simple sine waves. Echo. So just to hear what the echo sounds by itself, it's reflecting back, and we'll hear that like this. Bop, 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 bop. So exact reflections of the original sound. And then our reverb will add this effect. Ambience. Okay, so let's hear the whole thing together. Okay, so then to take the experiment a step further, I wanted to hear what a synthesizer would sound like if we built out the major scale based on these same intervals that gave us the overtone series. Well, what does that scale sound like if we then take those notes and build a scale out of them? So what I did was I made another synthesizer here. In this case, I used a square wave, and I used the notes we received from the Overtone series and then divided them down so that I could build out a scale and play that on a keyboard and hear what it sounds like. So here it is in this case with a square wave. So one thing I noticed right away was that it has much more of a dominant seventh sound. So I took this to compare. I took it a step further, and then I went through and used the ratios given in P.D. Ouspensky's In Search of the Miraculous, as well as Joachim Berendt's The World Not a Brahma, The World is Sound, and built another synthesizer, this time using the sine wave, and used these other ratios that you can see in the documentation to make this new synthesizer. And then I used all the natural overtone series for each note. So you can see I have the fundamental plus 7 overtones here for each note, and I've built that out through several octaves to make this instrument. And the first thing I noticed right away was that it has a much stronger leading tone. So if you'll listen to the major scale here. That G sharp leading back to the A, that's the leading tone, and you can hear it has a very strong effect of wanting to return to A. So then I've gone through and I built out several octaves of this, and I want to hear how it sounds different. You see, just intonation is the natural scale and the natural tuning system that singers will tend to use, and also was the only tuning system before the time of Johann Sebastian Bach. In Bach's time, they figured out, because of the phenomena of quantization, which is the way our minds actually correct minor errors and make them sound good to us still, you could take all the notes across the scale and make them slightly flat or slightly sharp to make the intervals between each note even. That makes it possible to modulate between several keys in a single piece, and that's called tempered pitch. And Bach wrote a whole several series of songs that were meant as lessons for his students to learn from how to work in this new tuning system, tempered pitch, which made it so you could modulate between keys. Now, modulation isn't really possible with a just intonation tuning system, but the intervals are very precise and clean, and I wanted to hear that with this synthesizer, and so that's what I've done, and we also have the overtones built out from it. And I think it gets particularly interesting when you start hearing chords and the interplay of multiple overtones. So let's hear that with, here's just the basic scale. And to demonstrate the use of that strong leading tone, here let me play a major chord, a dominant seventh chord on E that will lead us back to, I'll play A, E, A, so that you can hear that strong leading tone in effect here. And finally, let's add our filters and hear what all this sounds in a musical context. Thanks for watching.